Hi, in this video I am going to discuss 2002 physics past paper essay electricity question which is from potentiometer. Well, the question goes as the standard cell E0 in the circuit shown below has an EMF of 1.0 volt. The other cell has an unknown EMF E and internal resistance simple R. Q is a resistance box, S is another resistor, and G is a center zero galvanometer. Okay, the question number, Roman number 1. A resistance box P is now connected across X and Y. When P equals 20 ohm, it is found that the deflection of the galvanometer is 0 for Q equals 17 ohm, right? So when we connected a resistance box P, right? So when P equals 20 ohm and Q equals 17 ohm, the deflection of the galvanometer is 0. And again it says when P equals 40 ohm, it was found that the deflection is 0 for Q equals 35 ohm. Q equals 35 ohm. Okay, find the EMF E and the internal resistance R of the cell. So they have given us these values and then we want to find the EMF of this cell and the internal resistance of that cell. Okay, so first now we can see when P is 20 and Q equals 17 ohm, the galvanometer deflection is 0. That means no current passing through it. That means this potential difference is balanced by this one, right? The potential difference, this potential difference is balanced by this one. Okay, so now I can equate these two potential differences, right? So let's assume the current through this potentiometer circuit in this circuit is capital I, right? So we assume when the current is I, right? So I current only pass through this circuit because galvanometer reading is 0, therefore no current through this one. Now I can write here this, let's say I take this value, so the P, the resistance of P RP and resistance of Q RQ. Okay, so this potential difference is equal to this one, so I can write I into RP is equals E0, right? But here we know the value of E0, the RP value, the resistance is 20 ohm, but we don't know the current, right? So in order to find the current, I can use Kirchhoff law to this potentiometer circuit. Okay, so I get E equals I into RP Q plus internal resistance simple R, right? So now I can consider now these two equations, and now I can subject I here instead of from this equation I get, I can substitute I here, right? From this equation now we have I equals E0 is E0 is 1 volt, 1. RP value is either I can take I equals E0 divided by RP and I can subject that here. So I get E equals E0 over RP into RP plus RQ plus simple R. Okay, and now so I take this equation here, E into Rp equals E naught into Rp plus Rq plus simple R. Now let's put these values, then from we get E into Rp is 20 is equal, E naught is 1, and Rp is equals to 20 again, and then Rq is 17, right, and plus simple R. So we have 20E is equals 37 plus R. This is I can take this as one equation. I take 20E minus R equals 37. This is equation 1, and then again I can put these values, and then I get here Rp is 40, so 40E equals E naught 1, Rp is 40, and then Rq is 35 plus simple R. So from this I get 40E 40E minus simple R equals 75. 40 plus 35, 75. This is my equation 2. So now I can solve this equation 1 and 2 and find the values of E and R. So let's do that. So now if I subtract these two equations, I can get rid of the R terms, right? So I'm writing equation 2 minus 1. Let's see what would I get. So 40E minus 20E, so R terms cancels off, is equals 75 minus 37. So 20E is equals 75 minus 37, 45, and 38, am I right? Yeah, 38. So E equals 38 divided by 20 is 1.9 volt. So this is the EMF of the cell, and then we want to compute the internal resistance. That thing can be found from either one of these two equations. So if I consider from 1, we have take here 37 plus R equals 20 into E. So R equals 20 into E is 38. 38 minus 37, so R equals 1 in the units of ohm. So now we found the EMF of the cell as well as the internal resistance of the cell. So this thing is done. And the Roman number 2. Instead of the resistance box P, a nichrome wire of cross-sectional area 3 into 10 to the power minus 7 meter squared and length 10 meter is now connected across X and Y. It is found that the galvanometer deflection becomes 0 when Q equals 53 ohm. Find the resistivity of nichrome. Find also the current through the nichrome wire. Okay, now first nichrome wire is connected here, so it has a resistance. Let's take that nichrome wire's resistance is some R in. Okay, so similarly now I can write down this equation here, E into Rn, because now instead of the P we have nichrome wire, it is resistance. I take Rn is equals E naught into Rn plus Rq plus simple R. So E, we found that value is 1.9, right? 1.9 into Rn is equals E naught is 1, and then Rn here plus Rq. The value of Rq is 53, because this balance when Q is 53 plus simple R is, we found that is 1. So we have taking Rn to this side, Rn we have 1.9 minus 1 is equal 53 plus 1 54. So we get here 0.9, no? So Rn to 0.9 is equal 54. So if I multiply both sides by 10, I get Rn into 9 equals 54 into 10. So 54 is 6 into 9. So 9 cancels off. So we get Rn is equals 6 into 10. Therefore 60 ohm. In this problem they are asking us the resistivity, not the resistance. So in order to find the resistivity, we can consider Rn equals rho L over A, where L and A values are given. So substitute those values, we can find the rho. Okay. So from this rho equals Rn into A divided by L. Therefore rho equals Rn 60 into cross-sectional area given as 3 into 10 to the power minus 7 meter squared divided by length. Length of the nichrome wire is 10 meters. 10. So here 0 cancels off. So rho equals 6 into 3, 18 into 10 to the power minus 7 units as ohm meter. Okay, and then Roman number 3. What is the necessity of having a resistance? I think it should be what is the necessity of having a resistance is having a resistance is. So what is the necessity of this is? So we use here large resistor for the safety of this center zero galvanometer, because we know the galvanometer is a very sensitive instrument. If a large current passes through it, the galvanometer could damage or harm. So in order to avoid that, we use a large resistor in series to the galvanometer. So the answer should be, we can write for the safety of the galvanometer. And then also they ask what apparatus is used for S. For the S, what we have to use here is so in this part I will write down this S. What we have to use is, we have to use a large resistor, safety RS, and then we put a switch here to short the resistor once we are done with our this thing. I mean I will explain in the next question, because they ask how do you use S in order to find the balance condition, zero deflection accurately. So what we have to do is, first we have to put this off this switch. That means keep the switch is open, so the current only pass through this large resistor. Since this resistance is large, only a small current goes through the galvanometer, so we can safely take the balance point, right? And then when we get to the get near to balance point, that is now we have center zero galvanometer now. So here 0, like we have to get very close to 0. It can be, you can take very exactly to 0 or nearly close, that's fine, right? So we take the deflection very close to 0, we find the balance point like that. And then after that so this is we are doing approximately, right? We take the balance point nearly, and then after that what we have to do is we have to short this resistance. That means we have to put this switch so the current pass through this, So now we can take the balance point accurately. Okay, so that is how we have to do. Okay, so how do you use is in order to find the balance condition accurately. So first, find the balance point nearly by keeping the switches open, and after that short the resistor by putting this switch on, and take the galvanometer balance point accurately. Okay, I hope this is clear. Okay, take care.